Welcome to the second part of the reference triangles. In this lesson, I want to give you some examples of how to evaluate the trigonometric function when you are given the ratio for one of them and you are also given some information that tells you which quadrant the angle belongs. We've met all students take chemistry, that is the acronym to help us remember the sign of each of the trigonometric function in each of the quadrants. This is saying that all trig functions are positive in the first quadrant, and in the second quadrant, only the sign is positive, and in the third quadrant, only the tangent is positive, and in the fourth quadrant, only the cosine is positive. So we say all students take chemistry. So in this example 1, we are asked to find the 5 trigonometric function of theta, where we are given the sine theta to be 3/5, and we are told that theta lies in the second quadrant. And by the way, instead of saying the second quadrant, they can actually give you the value of theta in radians. So we know that this is 0 radian, this is pi/2, which is 90 degrees. This is pi/2 radians, and this is pi radian, which is the 180 degrees. And this is 3 pi/2 radian, which is the 270 degrees. So in any case, we know that this is going to be in second quadrant. So let's draw the reference triangle. So that's the theta there. So we know that here we are told sine theta is 3/5. So we know that sine is opposite over hypotenuse, which is the SOHCAHTOA. So opposite will be 3 in this case, and the hypotenuse is 5. So we don't know the value of x because this is a right triangle. You can use the Pythagorean theorem. So S is going to be the square root of 5 square minus 3 square. Okay, so S is going to be that plus or minus 4. So in this case, we know that the value is in the negative x direction. So x is going to be -4. So now we know all the sides of this reference triangle. So we can find the other 5 trigonometric functions. The cosine theta is going to be -4/5. You remember adjacent over hypotenuse, and the tan theta will be 3, which is opposite over adjacent. So it's going to be -3/4. Okay. So since we have already been given the sign, so the cosecant theta will just be the reciprocal of the sign. So it's going to be 5/3, and the secant theta will be the reciprocal of the cos, so it's going to be -5/4, and the cotan theta is going to be -4/3. So these are the remaining 5 trigonometric functions for this particular example. So that is how you use this reference triangle when you are given a ratio and the quadrants. So in example 2, we are given that the tan theta equals to 3, and we are in quadrant 3. Again, instead of saying quadrant 3, they might put it like this, that it is between pi and 3 pi/2. So that's quadrant 3. So let's draw the reference triangle. So we know that tan theta is opposite over hypotenuse. Tan theta will be 3. So 3 is just the same thing as 3/1, okay, because 3 divided by 1 is still 3. In quadrant 3, we have the negative x value and the negative y value. So the opposite in this case is just going to be -3, and the adjacent is going to be -1. So that is why we have tan theta to be +3, because the negative cancels out the negative in this case. So now we don't know the R, so the R2 can be found using the Pythagorean theorem. So we know that the R is going to be the square root of -3 square plus -1 square. So in this case, our R is going to be the square root of, so -3 square will be 9, 9 plus 1 will be 10. So the square root of 10. So we know that this is the root 10. So we can now find the other trig functions. Sine theta, in this case, is going to be -3/√10. We might want to simplify this. So sine theta, just so you can simplify by multiplying the numerator and the denominator by the square root of 10. So that is going to become -3√10 divided by 10. Okay. Cos theta is going to be -1/√10. Okay. and it's going to be equals to negative root 10 over 10. Okay, that is if you multiply it the way I show you for sine. So let's go to the reciprocal now. The cotangent theta will now be 1 over 3 because it's just going to be the reciprocal of the tan. And then the cosecant theta will just be the reciprocal of the sine. So it's going to be negative root 10 over 3. And then the secant theta will just be the reciprocal of the cos. So it's just going to be negative root 10. And that's it. Okay. So for this example 3, we are asked to find the other 5 trigonometric function of theta given this constraint. So we are told that the cotangent theta is negative, okay? So that means tan theta in this case is negative 1 over 3 because it's just going to be the reciprocal of that. But the cosine theta is positive. So again, let's remember quickly, all students take chemistry. So we are told that cosine theta is positive, but the tan theta is negative. So we are in the fourth quadrant. So we are in quadrant 4 in this case. So let's draw the reference triangle. So it's going to be quadrant 4. So that's our theta. So in this case, the opposite is going to be negative 1 and the adjacent will be positive 3. Okay. So because we are in the negative y direction and the positive x direction. Okay. In the fourth quadrant. So now that we know that, we need to find the value of r. So using the Pythagorean theorem, r is going to be the square root of 3 square, which is going to be 9, plus negative 1 square is just 1. So r is equal to root 10. Okay. So r equals to root 10. So now we can just do sine theta. So sine theta is going to be negative 1 over root 10. Okay. So you want to clean this up a little bit by multiplying it in the numerator and the denominator by the root of 10. So sine theta is going to be negative root 10 over 10. And cos theta is going to be 3, which is the adjacent, over root 10. So again, if you multiply by the square root of 10, okay, both the numerator and the denominator, you're going to get that cos theta equals to 3 root 10 divided by 10. Okay, then the cosecant theta will be the reciprocal of the sine, so it's just going to be negative root 10. Okay, and the secant theta will be the reciprocal of the cosine, so it's just going to be root 10 divided by 3. So we've already found tan and the cotangent, and that is the entire 6 functions for this question. So in this question, we are given the cosine theta to be negative, and tan is also negative. So again, all students take chemistry. So cos and tan, they are both negative. So that means we are in the second quadrant, because in the second quadrant, only sine is positive. We are going to just draw our reference angle again. So cosine theta is adjacent over hypotenuse. So adjacent will be this. So we know that we are in the negative x direction. Okay. So this will be negative root 5. Okay. And the hypotenuse will be 3. So we need to find this distance y. So y in this case is going to be, using the Pythagorean theorem, is going to be 3 square, which is 9, minus root of 5, negative root of 5 square, just going to be 5. Okay. So y will be square root of 4. Okay. And since we are dealing with the positive y direction, okay, positive y, so y is going to be the 2. So this is 2. So now we need to find the cosecant theta, but cosecant theta is going to be the reciprocal of the sine, okay? The reciprocal of the sine. So let's find the sine theta. Sine theta will be opposite, in this case 2 over hypotenuse, which is 3. So cosecant theta will be 3 over 2. Okay? So thank you so much. Please remember to subscribe.